Japan and the United Kingdom have decided to work closely together on the development of next-generation fighter jets in order to get the most bang for their buck. As a result, the FX program from Japan and Tempest from the United Kingdom will be the world's first sixth-generation fighters, both of which are scheduled to fly in the early 2030s. According to at least one source, the two programs will result in a single fighter design with minor modifications to meet the specific needs of each nation. So in today's video, we'll show you how Russia was taken aback by Japan's new aircraft. Make sure to watch all the way through and subscribe for more. Let's get started. The Tempest fighter was first shown at Farnborough in 2018. The Guardian, on the other hand, claims that the first Tempest fighter will take to the skies in 5 years. The new fighter will replace the Typhoon fighter, which was developed in the 1980s and was effective but lacked stealth and other modern requirements. The F-22 Raptor fighter was originally intended for Japan to replace its outdated F-15s, but U.S. legislation prohibits the F-22 from being transferred to another country. Japan is buying more than 150 F-35s, but it still wants a specific air superiority fighter. The X-2 fighter technology demonstrator flew in 2016. As a result, efforts were made to develop the F-3, a new air superiority jet that would fly for the first time in 2028 and enter service in 2035. After the U.S. refused to sell F-22 fighter jets, Japan began developing a new sixth-generation fighter jet. In this video, we'll look at some of the plane's unique features. The U.S. rejected the F-22 for Japan, instead promoting the Japan FX plan. The program began in 2009, but because the United States Congress prohibited the aircraft's export to protect its technological secrets, including its extensive use of stealth, Japan was forced to develop its own modern fighter with stealth features and other cutting-edge systems. Aircraft comparison: Brazil's KC-390 versus Japan's Kawasaki C2. The Mitsubishi Heavy Industries built X2 is the first experimental stealth technology demonstration for the sixth generation of aircraft. This plane is used to practice stealth technology and prototypes. On April 22, 2016, the X2 successfully completed its first flight from Nagoya Airfield to the JASDF's Gifu Airfield. When compared to the GE F-110 engine, this engine is smaller but no less powerful. The XF91 is a twin-redundant, dual-spool, axial flow afterburning turbofan with a 6-stage high-pressure compressor and a 3-stage fan. The declared thrust level of the prototype engine is 11 tons. Future fighter engine development, on the other hand, aims for a maximum thrust of 20 tons. The XF9 has a high combustion temperature of 1800 degrees Celsius. Given its power, it's surprising how light the SF9 is. The XF9's General Electric F-110 engine inlet, for example, is 30% smaller than the F2's. The hydraulic actuator has been replaced by an electric actuator. Although hydraulic actuators are typically used to control the flaps and other oscillating parts of fighter jets, Japan uses electric actuators for the FX program. Although the electric actuator can be integrated into designs, the hydraulic actuator takes up more space and has more limitations, allowing for greater flexibility in the aircraft's body design. Other benefits include reduced body weight and increased aircraft mobility. Electronic actuators are used in the control, power, and leg brake systems of fighters. Adhesive bondings are replacing fasteners. A new fighter aircraft level is also rumored to be in the works. The adhesive molding on this aircraft will be replaced with fewer fasteners. By using adhesive molding to bind composite materials together, fasteners can be eliminated. This procedure is known as Integrated Fastener Structure Technology. Heat shield technology enables the use of aluminum alloys and carbon fiber reinforced polymer to reduce weight close to the engines. It has flyby optics and 3D vectoring thrust control. This aircraft has 3D thrust vectoring similar to the Rockwell X-31, with 3 paddles on each engine nozzle. This allows for quick aircraft movement and supports a wide range of flight paths. Furthermore, data are processed 100 times faster than with wires thanks to the display of flyby optics, a capability unique to this aircraft. It has benefited from its immunity to electromagnetic interference. This aircraft can also repair its own flight controls, allowing it to detect flaws or damage to its flight control surface, maintain, adjust, and fly in a controlled manner. The aircraft will be outfitted with the F-35 radar variant. The FX uses sensors already installed in the aircraft to more effectively detect stealth aircraft. A passive radio frequency sensor, an active electronically scanned array radar, and an infrared camera are among the sensors. The FX is equipped with an RF self-defense system to counter threats from aircraft, air-to-air missiles, and surface-to-air missiles. Which of the following sensors is most likely to be found in the wings and tail? By being aware of the threat and instantly and globally undermining its radio signals, the system performs both ESM and ECM. It is looking for global collaboration to help pay for research expenses. The program is expected to cost $48 billion. As a result, Japan is considering collaborating with the US and the UK. It may give the UK more relevance than the US for a variety of reasons. According to multiple reports, the US was willing to give Japan access to some F-35 software as early as mid-April 2019 in exchange for cooperation on the development of the FX fighter. The specific agreement for Japan's FX program, however, has yet to be determined. Japan's interest in assisting India in the development of the AMCA 5th-generation fighter plane has yet to be determined. Let's discuss its design. Despite the fact that the 6th-generation aircraft is still in its infancy, numerous distinguishing characteristics have emerged to define what a 6th-generation fighter is. All 5th-generation deserving skills are for air superiority, ground attack, and other modern skills in particular will need to be improved. The aircraft industry is less concerned with the close-quarters dogfighting that characterized 20th century aerial combat. However, cyber conflicts, ground assaults, and space conflicts are becoming increasingly important. However, the use of missiles with a range beyond visual range remains critical. The ability to operate in either manned or unmanned mode will almost certainly be included in the next generation of jet fighters. 6th-generation airfighters like the F-35 and the 5th generation will need to integrate with a diverse range of other jets, drones, soldiers, and sensors in a dense network designed to provide warfighters with a comprehensive picture of the battle space. To achieve the performance characteristics expected of a 6th-generation fighter, various design components will be used. The aircraft's brains, advanced digital platforms with onboard AI, networking capabilities, data fusion, and advanced communications technology will be the foundation of 6th-generation technology. The jets will have some components that work in tandem, making it easier for pilots to work with the machine. As a result, some new fighters will include virtual cockpits displayed within the pilot's helmet, providing the pilot with 360-degree visibility and a modern instrument panel. 6th-generation fighters, like their predecessors, will require cutting-edge stealth technology, especially as air defense systems become more effective. Variable cycle engines, which can operate effectively in a variety of situations, including cruising without consuming a lot of gas and providing high-end thrust and performance, should be included in the new jets. Experts believe that 6th-generation aircraft will be equipped with CIWS, a popular directed energy weaponry. According to the TASS news agency, Russia has used a 5th-generation prototype that is currently undergoing flight tests to test various hardware components for a future 6th-generation fighter jet. According to Vladimir Mikheyev, advisor to the first Deputy Director General of Concern Radio Electronic Technologies, a division of Russian Technology State Corporation, various parts of the new jet have reportedly been tested on the Sukhoi PAK-FA Prospective Airborne Complex of Frontline Aviation T-50 prototype. The 5th-generation fighter jet and ground-based equipment are currently being used to test standalone solutions for the 6th-generation fighter. According to Mikheyev, who spoke to the TASS news agency on July 11, distinct components of the navigation and flying systems have already been installed on PAK-FA. The PAK-FA, a 5th-generation multi-role single-seat twin-engine air superiority deep air support fighter, will be used by the Russian Air and Space Forces in 2018. The name of the aircraft will be changed for the production model. In India, the prospective multi-role fighter is a prototype for the Indo-Russian Sukhoi HAL 5th-generation fighter aircraft project. That's all for today's video. Thanks for watching, and don't forget to like, share, and subscribe to our channel for more updates.